Welcome to this explainer. Today, we are cracking the code on a notoriously tricky Cambridge mathematics topic, inverse functions. Specifically, we're diving deep into syllabus code 0606 and the precise relationship between exponential and logarithmic functions. Now, if you look at examiner reports, we see two types of candidates all the time. First, there's Alex. Look at Alex's answer here. See all that red ink? Alex is undoubtedly brilliant, but he completely overloads his answers with raw mathematical facts and absolutely zero analysis. Then, right next to it, there's Sam. Sam rushes. He completely misses the specific command word requirements and just hemorrhages easy method marks. Our absolute focus today is to level up those answers, apply a proven strategy, and literally transform those red pen marks into green check marks. Let's jump right in.
To do that, we'll be opening up the examiner's playbook and working through 5 key sections: the core concept, theoretical foundations, the 5-step methodology, critical examiner alerts, and finally, evaluative thinking.
Section 1. The core concept.
Okay, I really want you to listen to this quote. One of the most misunderstood areas in additional mathematics. That's not just my opinion. That is a direct quote from a senior examiner. Principal examiner reports continually highlight that this specific concept is a massive, massive stumbling block. And you know why? Because students like our friend Alex treat it as a rote memorization exercise, while students like Sam treat it as a literal race against the clock. Both of them completely fail to grasp the fundamental mechanics at play. Look, misunderstanding this foundational relationship is like building a mathematical house on quicksand. The moment a question gets complex, the whole thing just collapses. We need to demystify this immediately so you can avoid the exact traps that cost thousands of prepared candidates their top-tier grades every single year.
Here is the absolute crucial truth you must internalize. The exponential function, e to the power of x, and the natural logarithm, ln x, are exact mathematical inverses. I want you to think of them as perfect opposites, right? Whatever e to the power of x does to a value, the natural log undoes, and vice versa. It really is that elegant. If you apply the natural logarithm to e to the x, boom, you are simply left with x. This isn't just some quirky little math fact to memorize. It's a profound mathematical relationship that literally allows you to solve complex equations where your variable is trapped up in the exponent. When Sam rushes through a past paper, he completely forgets this elegant symmetry and tries to use brute force algebra, and guess what? It leads to an absolute mess of calculation errors. Understanding this inverse relationship is your primary weapon for unlocking equations across multiple Cambridge syllabus codes, including 0606, 4024, and 4040. To structure this perfectly, top students use the Peel framework: point, evidence, explanation, link. You make your point about the inverse, provide the mathematical evidence, explain the step, and link it back to the question. We are going to break that down deeply in a moment. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. Theoretical foundations.
So, to truly secure those marks, we need to understand exactly how examiners are theoretically assessing this concept. It's not just about crunching numbers. The assessment objectives target 3 completely distinct cognitive domains: knowledge and understanding, application, and analysis. This means examiners are demanding logical, structured mathematical progression rather than just superficial calculating. When you see a command word like show that or justify, you absolutely cannot just dump raw numbers on the page like Alex does. You have to establish the mathematical relationship. You must show clear sequential working. You have to explain your algebraic steps, like explicitly stating why you apply the natural logarithm to both sides of the equation, and then connect your final value back to the actual context of the question. Top-tier candidates clearly define the inverse relationship before they ever apply it algebraically. Let's test this. I'm putting 30 seconds on the clock right now. Look at the 2 answers on your screen. Which one correctly follows that Peel framework we just talked about? Is it the one that just shows the raw calculation, or the one that actually explains the inverse relationship first? Time's ticking. Yep, the second one. That explanation step is exactly where the big marks are hiding.
Section 3. The 5-step methodology.
All right, let's look at the exact procedural framework needed to secure those critical method marks. This is how we transform those red pen marks into green check marks. This is the standardized 5-step sequence examiners are actively looking for when you deconstruct a question. Step 1. Identify T elements. Is this an e to the x problem or a natural log problem? Step 2. Apply relevant principles. This means recognizing their inverses so you can safely isolate your variable. Step 3. Execute your analysis with clear working. Step 4. Verify your results. For example, you have to ask yourself, does the mathematical domain restrict certain negative answers? Step 5. Present in the appropriate format. Look, when students stop skipping directly to step 3 and actually start identifying the elements first, and when they deliberately slow down to verify their results, their marks drastically improve. We're going to do this live. I'm putting 60 seconds on the clock. Grab a piece of paper and try rewriting Alex's flawed answer using these 5 steps. Go. Okay, time's up. Just looking at how you mapped out those first 2 steps mentally, that right there is how you build exam day muscle memory. That is the mathematics success blueprint.
Now, throughout these 5 steps, your presentation absolutely has to follow strict conventions. You must prioritize clear notation to actually prove your analytical depth to the examiner. They are looking for clear, unambiguous working. Think about it. If you drop a single negative sign, or if you just forget to write the natural log ln clearly on one line, your entire analytical house of cards just collapses. Proper headings, correct terminology, and appropriate formats show the examiner that you are the one in total control of the mathematics. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Critical Examiner Alerts.
Let's kick off our interactive workshop and move to the specific traps and pitfalls that cause even the most prepared candidates to hemorrhage marks. According to Cambridge Examiner data, these are the top 3 examiner warnings. Number 1, wrong approach for the context. Number 2, forgetting format and presentation. And number 3, answers not specific to the context. This highlights a severe disconnect. Students are mechanically applying the e to the x and natural log relationship without looking at what the data actually means. Let's do challenge 1, data scan. I'm putting 60 seconds on the clock. Look at this complex data chart on your screen. Can you extract the core mathematical trend happening with the exponential curve before the timer runs out? You have to see how it relates to the given context. Take our friend Sam's flawed answer from earlier. His working completely fell apart because he used the wrong approach for the context. He actually forgot that the natural logarithm is completely undefined for negative numbers. This is where those examiner warnings become your ultimate cheat sheet.
This brings us to challenge 2, find the flaw. A major examiner alert points out that candidates consistently confuse key mathematical terminology. I'm putting another 60 seconds on the clock. Look at this flawed sample paragraph on your screen. Can you identify the exact sentence that is losing marks? Where's the flaw? Right there. They didn't define their terms. You absolutely must systematically define your terms before executing your analysis. Top candidates define their mathematical environment, like explicitly stating the domain of the logarithmic function, before they ever operate within it. Doing this eliminates ambiguity. It locks in those crucial communication marks that examiners are looking for across all higher-level syllabus codes from 0606 all the way to 9231.
Section 5. Evaluative Thinking.
So, what really separates a standard passing grade from a top-scoring, top-tier candidate? It all comes down to higher-order assessment objectives that push far beyond basic calculation. A passing candidate knows how to do the math. A top-scoring candidate knows why they are doing the math, when to apply specific rules, and exactly how to prove their logic is completely bulletproof to the examiner.
Top-scoring candidates demonstrate evaluative thinking by questioning assumptions and justifying every single mathematical decision with evidence-based reasoning. This brings us to challenge 3, speed writing. I'm giving you 30 seconds to write one perfect Peel paragraph explaining an inverse function. Go. Okay, time's up. Does your paragraph show evaluative thinking? We teach a system of 3 rules that absolutely guarantees top marks if you follow them. Rule 1, command word decoding. You have to know exactly what the question is asking. Rule 2, Peel framework application. Point, evidence, explanation, link. Structure your math sequentially. Rule 3, time management matrix. Don't rush like Sam and don't overwrite like Alex. By doing things like questioning your own assumptions, say actually checking if your calculated value for x fits within the defined domain of the logarithmic function, you prove to the examiner that you are considering different mathematical perspectives and justifying your decisions. To master this completely, your framework must evaluate alternatives and compare approaches, successfully hitting the descriptive, analytical, and evaluative levels. That is the complete mathematics answering system. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCS to excel in your Cambridge examinations. Subscribe right now to at AceTheExams_IGCS and click that bell. Don't let another exam pass you by.
As you apply this methodology going forward, you have to ask yourself the hardest question. When facing a complex e to the power of x or natural log problem, are your answers merely descriptive or are they truly evaluative and logically bulletproof? Keep that in mind to ensure you unlock every possible mark. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.